In the early 1980s, a Japanese physician named Ching Li began studying something that traditional Japanese forest medicine had suggested for centuries: the health effects of spending time in forests. What he found, and what his subsequent 30 years of research have increasingly confirmed, is that the health benefits of forest exposure are not primarily from exercise, fresh air, reduced noise, or beautiful scenery. They come primarily from breathing, specifically from inhaling the volatile organic compounds that trees and plants continuously release into the air around them. These compounds, called phytoncides, are the forest's own antimicrobial defense system. Trees produce them to protect themselves from bacteria, fungi, insects, and other pathogens. And the research has established that when humans breathe these compounds, they produce biological effects that are measurable, specific, and extraordinary. The most comprehensively studied phytoncides for human health effects are alpha-pinene and beta-pinene, the terpene compounds responsible for the smell of coniferous forests. Of these, alpha-pinene and beta-pinene have the most extensive human research base, including trials documenting specific immunological and neurological effects. The landmark research found that participants spending 2 to 3 days in a coniferous forest showed significant and sustained increases in natural killer cell activity. NK cells, the immune cells most critical for cancer surveillance, were dramatically and durably activated by the phytoncide exposure of forest bathing. And then came the finding that changes the practical implications entirely. Li's group conducted a follow-up study using hotel rooms with phytoncide diffusers. The NK cell response, the 50% elevation and the 30-day persistence, was reproduced in the hotel room setting with no forest. Indoor phytoncide delivery produces the same immune effects as outdoor forest bathing. This finding transforms forest medicine into a daily home practice, requiring a diffuser and specific essential oils. After 50, when NK cell activity is declining, daily indoor phytoncide exposure provides a specific, evidence-backed, daily dose of forest medicine. A daily dose of forest medicine at a cost of approximately $0.50 per day. Let's establish the specific biology of the most important phytoncide compounds and the mechanisms through which they produce their effects: alpha-pinene and beta-pinene. These are bicyclic monoterpenes, the primary aromatic compounds of most coniferous trees including pine, spruce, fir, cypress, and cedar. They constitute 40 to 80% of the volatile output of coniferous forests, making them the most abundant phytoncide compounds in forest bathing environments. When inhaled, alpha-pinene crosses the blood-brain barrier with remarkable efficiency due to its small molecular size and lipophilic character. Research has found that alpha-pinene concentrations in human brain tissue increase measurably within 30 minutes of inhalation. The NK cell activation mechanism of alpha-pinene and beta-pinene involves their interaction with specific olfactory receptors. These receptors are not only in the nose but also in the lungs, the skin, and the immune cells themselves. NK cells and T lymphocytes express functional olfactory-type receptors that respond to terpene compounds. This direct terpene immune receptor interaction is the primary mechanism of the phytoncide NK cell activation effect. Research has found that alpha-pinene specifically increases the expression of perforin and granzyme B in NK cells. These are the cytotoxic molecules that NK cells use to destroy infected, malignant, and senescent cells. The phytoncide is specifically upregulating their killing capacity through the molecular machinery of cytotoxic immune defense. Beyond NK cell activation, alpha-pinene has documented anti-inflammatory effects in the central nervous system. It reduces neuroinflammatory markers in microglial cells by reducing TNF-alpha and IL-6 production. This anti-neuroinflammatory effect is additive with omega-3, quercetin, and resveratrol mechanisms. Alpha-pinene also inhibits acetylcholinesterase, the enzyme that breaks down acetylcholine in synaptic clefts. Acetylcholine is the primary neurotransmitter of memory and focus. Its preservation is the same mechanism used in cognitive-enhancing drugs. D-limonene, the primary terpene of citrus and several forest species, produces effects through the GABA receptor system. It activates GABA-A receptors in the limbic system, producing stress-reducing effects comparable to low-dose benzodiazepines. The cortisol reduction in forest bathing is substantially attributable to D-limonene's GABA-mediated stress reduction. Japanese hinoki cypress produces a specific terpene profile subject to rigorous research for cognitive effects. Study found hinoki phytoncides produced greater cognitive restoration, with improvements in attention and memory. Compounds like saponine and gamma-terpenine have direct cognitive effects through adenosine receptor modulation. The indoor phytoncide protocol has two components: the diffusion setup and the exposure timing that maximizes each specific biological effect. The diffusion setup. Diffuser selection. Ultrasonic cold water diffusers, which break essential oil into microparticles through ultrasonic vibration without heat, preserve the full terpene profile. Heat can alter the molecular structure of some terpenes, reducing their biological activity. Ultrasonic diffuser cost: $25 to $45 for quality units. Essential oil selection. The phytoncide compounds most comprehensively studied for human health effects are available in the following essential oils. Siberian fir has the highest naturally occurring alpha-pinene content of any commercially available essential oil, approximately 35 to 45%. The closest commercially available approximation to the phytoncide profile of a boreal coniferous forest. This is the primary oil for immune support and anti-neuroinflammatory effects. Black spruce, Picea mariana, high in camphene and beta-pinene, provides a complementary terpene profile to Siberian fir that broadens the receptor coverage. Hinoki cypress, Chamaecyparis obtusa, for the cognitive restoration and attention enhancement effects documented in research. More expensive than pine oils, approximately $25 to $40 per 10 milliliter bottle, but highly concentrated with only 2 to 3 drops needed. Citrus peel, sweet orange or bergamot, for D-limonene's cortisol reduction effect. Less expensive than coniferous oils and easily combined with them. The diffusion protocol. Morning session, 60 minutes, Siberian fir, 3 drops, black spruce, 2 drops. Diffuse during your morning protocol period. Immune activation and anti-inflammatory effects are most valuable during the morning period when the day's inflammatory and immune demands are beginning. Evening session, 60 to 90 minutes before sleep. Hinoki cypress, 2 drops. Sweet orange, 3 drops. The hinoki cognitive restoration effect supports the pre-sleep period. The D-limonene cortisol reduction supports the parasympathetic transition toward sleep onset. This evening session is specifically timed to complement the magnesium glycinate, L-theanine, and apigenin sleep protocol. Weekly bedroom diffusion overnight, 2 drops Siberian fir during sleep. Research finds overnight diffusion produces the most sustained and complete immune activation. Continuous low-dose exposure over 8 hours produces more complete receptor activation than the same total dose in a 1-hour session. Total essential oil cost: approximately 30 to 50 cents per day of diffusion. One-time diffuser investment, $25 to $45. The indoor phytoncide protocol connects to multiple existing protocol elements through mechanisms that make each more effective. Phytoncides and the senolytic protocol. NK cell activation from phytoncide exposure directly enhances the immune clearance of senescent cells. This is the same clearance that the fisetin and quercetin senolytic protocol is supporting through direct apoptosis induction. The senolytics eliminate senescent cells through chemical mechanisms. The phytoncide-activated NK cells eliminate them through immune cytotoxic mechanisms. 2 independent pathways to the same cellular cleaning outcome. Phytoncides and neuroinflammation. Alpha-pinene's microglial anti-inflammatory effects provide additional neuroinflammation control through the terpene receptor mechanism. This does not compete or overlap with the omega-3, quercetin, and resveratrol mechanisms. Additive anti-inflammatory coverage from an inhaled source. Phytoncides and acetylcholine. Alpha-pinene's acetylcholinesterase inhibition preserves the acetylcholine that is essential for memory encoding and focused attention. The magnesium L-threonate protocol supports the NMDA receptor function. Together, they preserve the acetylcholine signal and maintain synaptic machinery. Phytoncides and the nature protocol. Outdoor nature exposure produces cognitive restoration, cortisol reduction, and vagal tone activation. The indoor phytoncide protocol extends these effects to every day, regardless of weather, schedule, or nature access, providing a daily dose of nature's medicine even when physical nature access is impossible. Here is your specific action plan for this week. Order a cold water ultrasonic diffuser and 3 essential oils, Siberian fir, hinoki cypress, and sweet orange, from a reputable essential oil supplier. Ensure the Siberian fir specifies high alpha-pinene content. Total investment, approximately $50 to $80 for the diffuser and oils, providing several months of daily diffusion. Begin the morning diffusion session tomorrow. 60 minutes of Siberian fir and black spruce during your morning protocol. Notice the cognitive clarity and the emotional calm that phytoncide exposure produces within the first session. The subjective experience of terpene exposure is itself an indicator of the objective neurobiological response. Add the evening pre-sleep diffusion session, hinoki cypress and sweet orange for 60 to 90 minutes before sleep. Notice the cortisol reduction and parasympathetic shift that D-liminene's GABA activation produces in the evening transition period. Next week on Neurovitality. After 50, we are going into one of the most surprising and most important areas of emerging brain health science, the specific role of chronic pain, not just acute pain, but the low-grade chronic pain that most adults over 50 accept as a normal part of aging, in accelerating cognitive decline. Research has confirmed that chronic pain produces measurable gray matter loss in prefrontal and cingulate regions, elevates neuroinflammation, impairs sleep architecture, and consumes the cognitive resources that aging brains can least afford to spare. And specific interventions address the neurological component of chronic pain in ways that most pain management approaches completely ignore. Stay sharp, stay breathing the forest, stay vital. I will see you next week.